XR
This meeting is being recorded.
and AI for fashion design. Kindly let me know if you are able to see the slides moving forward. So about myself, my background is in computer science. I'm passionate about design and the intersection of design and data and building for the web. So I've been a web developer for more than 10 years and a designer for the longest time ever since I was a kid. Uh, and I believe 3D or 3D interfaces will be the next big thing at solving real world problems, especially when AI is involved. So a brief introduction about Klurdy Studios. We are a design studio. We create XR applications uh, by using creative AI or machine learning. We have our own flagship product that we'll be launching next month, which is basically a design platform that allows brands to tell their stories interactively with the help of AR and motion graphics in an intuitive and easy to use manner. And we started off as a clothing brand, so we still have our own clothing line. So, brief overview of what we'll be going through today. The first section will go through some algorithm definitions. Here, I'll do my best to keep it simple. I won't use big words. And basically, we'll look at the different algorithms that
We couldn't
shape.
see the slide changing.
Yes, sorry. If you just give me 1 minute, let me share the actual again. Where is it? Let me share the entire screen. Um, are you able to see the slides changing now?
Yes.
Sorry about that.
Yeah.
So we were here looking at the contents of the talk today. So basically, we'll go through the algorithm definitions, and this will involve looking at the different types of algorithms that actually are being used in to create immersive experiences, with a key focus on the fashion design space. Uh, from that, we look at the applications of these algorithms. What are some of the use cases in the fashion realm that people can use to create immersive experiences? And finally, we look at some of the challenges that personally I've encountered with Klurdy Studios and some of the key opportunities that I'm seeing coming out of uh, this field. So, in terms of algorithms, I think for XR or creating AR and VR experiences, you will be dealing quite a lot with computer vision algorithms. And computer vision, what does that mean? Computer vision is a branch of AI or machine learning, if you want to call it, or deep learning. So those are just some of the terms that are usually interchanged. So you'll hear some people say AI, some people say machine learning, some people say deep learning, but they kind of mean the same thing. So computer vision is like a branch of this field, and there are many other branches like natural language processing. That's where the chat GPTs lie. And so computer vision is a branch that enables computers to actually understand, to visually understand images and videos. And by this, I mean their computers are now able to understand the context and the different objects in images and videos. And videos is just basically um, a collection of images on different frames. So some of the key computer vision algorithms that we'll be looking at today are listed here, which will be pose estimation, image segmentation, object detection, image classification, body part segmentation, image in painting, guided image generation, and image embedding. So don't let these terms scare you. We will go through them bit by bit and have a look at some examples. So the first bit is pose estimation. So what pose estimation means is basically it's detecting and tracking the orientation of the human body parts in videos and images. So if you've worked in motion tracking before, or so basically it's kind of like understanding how the human body moves. And there are three different types of pose estimation algorithms. The first one is skeleton based model. This is kind of like the most popular one out there that is currently being used. And basically, it's this one, the first one that has like a stick man. So what it does is if you give it an image as the input image that has a person, it can be able to draw the skeleton of that person. And by skeleton I mean, if you've worked with the 3D models before, you I'm sure you're familiar with the rigging process, where you kind of like create the bones. So these dots signify like the different joints. They are called key points. So these are the different joints of a human body skeleton, of a human skeleton, and the lines represent the different bones that are connected by these joints. So by giving this model an image of a person, it should be able to draw out the skeleton and the key points. So using this information, you can actually build out AR experiences, and some models actually output this information in 2D format or 3D coordinates. They can give you 3D coordinates. The second type of pose estimation is contour based model. This is basically they kind of like segment the human body into different segments or different parts, and then they estimate the pose by joining the different parts together. So like for example for this, they'll have like the head as different parts, the arms as different parts, and then the different parts are kind of like joined together to actually form this pose. So this is usually better than the skeleton based model, because you can actually get how the different joints come together. The last one is volume based model. So volume based model, or the volumetric based model, is if you give it an image, it kind of like gives you like a 3D model of the pose of that person. And this is uh, has been quite popular of late, uh, in actually creating pose estimation or AR effects that use pose estimation. And if you're familiar with Snapchat or Lens Studio, this is the model that they use. But the most used one is the skeleton based model. So there are open source models out there. I linked one example here. One is from Google. They have a set of AI models under the brand MediaPipe. So MediaPipe has like a pose estimation model, and it's actually a skeleton based model, and it has 2D and 3D. It can offer 2D and 3D coordinates for each key joints. Let's move on to the next one. So the second one is image segmentation. Basically, this is taking a digital image and then grouping pixels that kind of like um, are part of a similar object together, and then creating a mask. So if you look at this example, this is an image of a person. So the model is able to segment the image of a person, and then create a mask around the person. So this is usually, like, for example, you're using Zoom. So I'm sure in Zoom you've seen a feature where you can have like virtual backgrounds. So this is the actual model that actually Zoom uses. It's called the image segmentation. So they're able to kind of like remove the background from real time, from images or videos. An open source example for this, still again, I'll refer you to MediaPipe, and I'll let you know why I'm referring you to MediaPipe for this, um, for this talk. MediaPipe is, in terms of image segmentation, it has more features. You can segment a person alone. You can segment a person's hair if you want to be like beauty effects for hair and stuff. And you can also segment a person if you want to segment their skin, the different clothings and accessories. So for accessory example, you can create a segment, you can segment out these sunglasses. The third computer vision algorithm is object detection. Object detection, it's focused on locating instances of objects in images or videos. So this is actually one of the most popular computer vision algorithms out there, and it's usually used to create like a bounding box of the objects that are in the image. So if you see this blue line and this other blue line, this is called a bounding box. So basically, it's a box that shows you the pixels that instance of an object appears in. And it's quite popular. It's being used in traffic systems, a lot of augmented reality systems when you want to, like, especially for education, if you want to educate someone about different types of objects. If it detects like a dog, it can overlay information about the type of dog, or etc., etc. So another example, open source example, is MediaPipe. Again, they have a really cool object detection functionalities.
May I
The
ask you, like, I use YOLO. What's the difference between YOLO CV2 and the MediaPipe?
So there are different. There are very many models out there for object detection. YOLO, I think it's the main difference, if you look at them, is performance. You'd find they're usually like benchmark metrics when these guys are developing these models. They do similar things. You'd find YOLO might have um, a bigger list of the objects that it can detect. So maybe it might have like flowers and stuff like that. So that's one of the big differences in the object detection world, is how many objects has it been trained to detect. The reason why I'm specifying on MediaPipe is optimized for to work on device. So basically, it can run on a phone, or a Raspberry Pi device, or it can also run on a server. So for AR or for XR effects or for XR experiences, immersive experiences, I think we've learned that having these models run on device improves the experience significantly, because it's a real-time experience. So data does not have to be sent to the server to be processed and then back to the user. So you can actually process everything as on the user's device, and then with that, it comes with the privacy. It preserves privacy. I hope I've answered your question.
Yeah, so as for Google's MediaPipe, because I use YOLO 9 right now for face detection, and I saw you have media pipe. What's the language for media pipe, and what's the, for example, like how to upscale? Is this like a more like a for AR, VR, or like a for, yeah, I want to see like the difference because I'm like
Yes.
Googling. Yeah. Okay, go ahead.
Yeah, so I think that's a very interesting question because one of the benefits of MediaPipe is it runs it supports multiple languages, so it can run on the browser, so JavaScript. It can run on Android. It can run on iOS, and it can be used with Python. So it does support a large number of devices, and it has been battle tested. So Google uses it internally. So if you use Google Hangouts, it uses Google Media Pipe to do like, for example, the removing of the background. um, it has been integrated in so many Google's products, and it has been developed for simplicity. So it's really easy to actually get it in your project and start using it. The documentation is really great, and it's easy to use, and there's a lot of support when you go to Google forums if you get stuck. I think that's something that I've found to be a bit important when choosing the technologies that we use.
Cool. Thank you so much. So yeah, so please go ahead. Yeah.
Yeah, but actually YOLO is actually also a good model. I believe also MediaPipe has facial detection and all those stuff. Um, I think I've used YOLO. I don't know if you know a platform called RoboFlow, or yeah, I think
Yes,
RoboFlow.
yes. I saw
Yeah,
it, but it charges. It charges money. So I was like, okay, it's very convenient. You can train, right? You can train your cups, you can train your personal stuff. But I prefer the free one because it's like the subscription fee is is not cheap. Did you subscribe it?
yes, that's why we opt for MediaPipe. It's an open
Wow.
source. You can use it. You can actually train it on your machine.
Hmm.
If you feel like extending it, you can use Google Collab, which is Google's like they have a free trial where you can access. You can run your machine learning projects, or experiments there.
Hmm.
So I think it's a pretty good solution so far. I've
Hmm.
used it I think since 2021,
Hmm.
and it comes with a lot of features.
Hmm.
Even the ones that I'm showing you, it's just like a small subset, but it is a house of many solutions, not just computer vision, but also if you want to do like audio and text, it also has like solutions for that. So for this, I think we can move on to the image classification. So for object detection is identifying the different objects in an image. For classification, it's a little bit different. It's like identifying the different categories of objects. So, for example, in object detection, as you can see here, we identified you can see a dog and a cat. That's what the model sees. But for image classification, it can go further. If it sees a dog, it can actually classify which type of dog it is. So maybe the model can be trained on identifying German shepherds and poodles. So given an image, it can show you yes, it is a dog, but which type of a dog is it? So that's called like which class of a dog is it? So that's like image classification. So it identifies the different classes of objects in an image. So here I've also linked Google's media pipe, but I've also added because now for Google's media pipe, the image classifier might not have exactly what you need for this case, which is fashion classification. So I've also created a link uh, to show you how to train your own fashion classifier. So this basically is an image classification algorithm that can be able to identify which classes of fashion items are in a picture. So if it's is it a sweater, is it boots, is it sandals, the likes. So TensorFlow, this link I've shared is from TensorFlow. So TensorFlow is the official framework for machine learning development from Google. It's they have a ton of models there. You can also check it out. And also for TensorFlow, it works on mobile or web, the browser. So the next one is image in painting. So for image in painting, I'd like to explain it using the old photography that we used to have. If you can remember the days of Kodak and the likes. So imagine having a photo that is damaged or has been cut. So how do you replace or how do you fix the damaged part of a photo? So image in painting is a technique that actually reconstructs images, the damaged parts of an image, and actually fills in or reconstructs those parts with the new pixels. So, for example, this image, this image, you can see this gentleman on the left has some scribbles. So maybe it was a kid playing with crayons or something. So you can see here the image is damaged, but if you pass it through an image in painting algorithm, it might be able to actually replace those pixels that have been damaged and actually reconstruct the image to kind of like almost 100% of the initial image. So here we have a lot of examples of open source models for image in painting. Some you can get them from Intel, but those are old school. So with this stable diffusion, they released an in painting feature that uses these large language models, and you can actually use prompts. And prompts is basically the text or commands that you offer to a large language model, instructing the model to do something. So I linked the image in painting solution from Stable Diffusion, which is again an open source solution. The next one is body part segmentation. This is a little bit similar to image segmentations, but a little more detailed. And it's basically identifying the different parts of a human body and actually like masking them. So you can see here on the image with this person here has been masked, and the different mask you can see there's the left face, right face, and the different body parts that have been identified in that image. So another solution, open source solution, is Google's Body Pix. It might seem I'm trying to upsell Google, but unfortunately at this time, they are the one of the few brands out there that have been building machine learning models that work on device, that work on device devices like phones or laptops without the need of a server, which is quite important for our use case in building augmented reality experiences. The other algorithms that we look at is guided image and 3D generation. So I'm sure you've seen text to image generation models like Stable Diffusion or Midjourney or DALI. So this is kind of similar to that, but with the twist. So it's kind of like text to image, but you condition the output using reference images. So this means that instead of just inputting text and then expecting an image as the output, you can actually control uh, what the output is. So for example, this is the input image of a person, and what this model does, it preprocesses the image using the skeleton based pose estimation to grab the pose estimation of this person, and then using this pose estimation, it actually now generates the image based on that prompt. So you can see, you can actually guide your image generations using different types of uh, image generation models. So for us, what we'll be looking at is control net. So control net is a model that was built on top of stable diffusion, and it has different pre-processing tasks. But I think for this talk we'll focus on something called Scribble, and I'll show you later on. The other one is a recent. I think it was released a week or 2 weeks ago. It's called Garment 3D Gen. This was created by Facebook Reality or Meta Reality Labs, and it's taking images or fashion images of or images of clothing, and then it outputs a 3D model of that garment. And we'll see how it works in a moment. The last one is image embedding. This is basically a technique that machine learning engineers or computer scientists use to represent images in computers. So how computers work is computers recognize zeros and ones. So computers work best with numbers. And for an image, for a computer or a machine learning algorithm to be able to process images, they need to be converted to numbers. So image embedding is the task of creating a numeric representation of an image. So basically what it does, for example, in this image, you can see this is an image of an ice cream that is different from this one. You can see this image is represented with a string of numbers or a stream of numbers or a set of numbers, as you call them, which is called vectors. So you can see this representation of this image and the representation of this image are not the same. So you find this one has a different this one is represented by a different set of numbers as compared to this one. So this image embedding algorithms are actually quite important in creating machine learning applications that are usually using images. And again, Google Media Pipe has a solution for that. So there's something that also Google released late last year, which is a no-code ML tool. It's a browser-based tool, and it is free. You can access it using the links outlined below, and it leverages TensorFlow, which is Google's machine learning framework, and TensorFlow Lite to actually create machine learning pipelines. So it's kind of like a visual block builder. You can actually, if you've worked with 3D editing softwares or 3D or AR publishing software. So you might be familiar with Node, I think it's called Nodegrass or something. The node editing functionalities of those software. So it's kind of like the same, where you can kind of like build nodes. So you can come and select like you want a node to do image classification, and then the output of that you pass it to image embedding and the like. So you can actually build complex pipelines or machine learning pipelines without writing a single code. So I believe this will be quite helpful for actually guys who are not experienced with coding as much, and they would want to like experiment with machine learning and see um, how to build this pipeline. So I'd really suggest that you look at that. So the second part of the section we look at now the applications, how these algorithms are actually being applied in the fashion realm, and these are um, the key uh, the key applications or use cases that we look at. The first one will be virtual try-ons. We look at garment design. We look at sizing. We look at personalization, sustainability, because fashion is termed as the second largest contributor to waste. Textile waste is the second largest contributor to these global warming problems. We look at brand verification. This is about fake products, and then virtual fashion shows and events. So let's start with virtual try-ons. So virtual try-ons, I'm not sure if you've come across this feature if you're a user of Snapchat. So where you can actually try on an outfit through AR. So actually, at Klurdy Studios, we in the middle of COVID in 2020, we teamed up with Snapchat, and then we joined their machine learning residency program, and we built the first full body virtual try-on features for that for that app. The ones that they had before were for shoes and eyeglasses, but we built the first um, full body virtual try-on functionalities with the help of their team, and we learned a lot in that process. We learned about the importance of having machine learning models running on phone, and the impact on performance, and the impact of performance in the user experience. So basically, virtual try-ons, what it means is you're actually bringing the in-person experience of people shopping in a store, in a physical store online. And this means that you allow customers to actually try on clothes and see how they look like wearing the clothes, but in a virtual fashion. It has been noted through research that a lot of online sales, a lot of returns from online sales are due to people not being able to visualize themselves wearing the clothes, or the images that we've also had cases where people say the image that they see is not what they receive or what they perceive them to be. So this functionality is actually has been a huge uh, beneficiary to fashion brands. And I believe I saw a recent a report from Snapchat that said through the brands that they actually engage to create these experiences for, they actually boost sales, fashion sales for those brands, as people get more comfortable shopping online. So for this, the machine learning algorithms that are being used here is pose estimation, and by pose estimation or styles transfer. But styles transfer is for 2D images, and what style transfer is means is you take a style or the artistic style of one image and apply it on another image. But this is for the style transfer is for 2D experiences. Since you're talking about XR, I think we'll focus on the pose estimation. So this is how it will look like. So in order to create a virtual try-on for 3D using pose estimation, the first thing is you'll need to have your clothing model in around a humanoid body, and that humanoid body needs to be rigged with the key joints that will be used to actually map the garment to the user who's trying the cloth. So here in the skin mesh has the actual outfit, and the outfit is modeled on top of a humanoid, and the humanoid has a rig that has a skeleton that has the different key joints. And then you have a photo of a person. So this can be a photo or a video of a person. So when you pass this through a machine learning model, so you pass this photo or the video of a person through the pose estimation model, and it gives you the actual key joints for this person. And what you do here is now on the left, is on the far right, sorry, is now try to align the key joints that you received from the machine learning model to show the pose of this person, and then you align it with the key joints of that skinned mesh. So for this demonstration, I left out. I did not do a lot of things. I wanted it to be rough so that you can actually see what is happening here. So you can see here, once you align it, you can go ahead and hide the body, the body of the humanoid that you're using, and then what you are left here is the asset or the 3D model of the outfit. So if I play this video, you can actually see the outfit. When someone clicks this swap styles, you can actually see that you can view the different variations of that clothing. So you'll see for this, it's a bit rough because you can see here, you can see like the hole or the where the arms were before hiding the humanoid. So you can remove this by adding the occluders or the occluders or something. So for this, that's how basically you build a virtual try-on using machine learning. There are a lot of post-processing that are being done here. So you'll find you'd want to convert because this is an image and this is like a screen space, and then you need to take it to world space. So you need to convert the key points, the skeleton points that you receive from the machine learning model from screen space to world space. So that's in brevity. That's how you build a simple virtual try on functionality. You'd find you might need to go deeper. So you'd see this lady. Um, she's wearing a bikini. So imagine if she was wearing like a long sleeve shirt and some pants. You'd find that this outfit it will be overlaid on top of of uh, of the long sleeve shirt and the pants, which is not the experience that you'd want, and that's something that's actually bothering the industry right now. So you'd find, like for example, in Snapchat, you'd find the virtual try-on functionalities. That's how it will work. So what we've the research that we've done is we've seen what we need to do is now use the body part segmentation model and identify the parts of of this human character that that needs to be removed. So you can find that the forearm and the right arm, this whole arm needs to be removed. Maybe if they had like a long sleeve shirt, and once you remove them, now you pass the image through an image in painting model, and then it paints now new arms for for that person. So again, it's something that is experience. The experience is still being developed, and there's a lot of opportunity in virtual try-ons, because I don't think there's a single entity that has quite hacked it, especially when it comes to like AR. For image based, I think it's working perfectly. I think Google Shops, I think Google Search has, they are trying, they have a virtual try-on functionality. I think it's being beta tested, but then they're using the 2D images. But for 3D or XR experiences, there's a lot of work and a lot of opportunities to be done. The second use case is garment design. So garment design is something that has been a bit of a challenge to a lot of people. So when I started Klurdy, I started hanging out with the fashion designers, and I actually ended up doing a course on fashion design, just for the fun of it, to understand, to learn what goes on in garment design, from conception to the end till manufacturing and distribution. And you'd find fashion designers, when they go through fashion design school, they come out and they pick a line of work. You'd find some just want to work with sketching concepts. Some want to do like the pattern drafting, and some want to do the actual sewing and stuff like that. So fashion design is a very big field when it there, and has different parts. But when it comes to 3D, the only solution is you'd find a fashion designer will come up with a sketch. The sketch is then passed on to a 3D artist who's been, or a pattern drafter who comes and creates this pattern. Now the pattern is this blue shaped thing here. You can see here at this side. So once that other fashion designer creates or the pattern drafter creates this, now this asset is now passed to a 3D artist. Now the 3D artist will use traditional this computer aided design softwares or 3D modeling softwares, for example like Clo 3D, where they model this pattern drafts around a mesh of a humanoid, and then they create the design, and then this design is now, they can now texture it and apply different materials on it, and actually be able to view how the fashion or how the garment will look like. And you can imagine, even before 3D modeling software, people had to, from after this process, they actually had to make the garment with actual materials and stitch it up, just to make a prototype and see if it's okay. So 3D modeling has actually helped the industry to prototype faster. But now this part of 3D modeling relies on 3D expertise, and you'd find a lot of fashion brands don't have uh, access to 3D expertise. And also you'd find that also in the world we don't have a lot of 3D artists who are actually venturing into fashion design. So this has become this is actually a real challenge when it comes to the uptake of uh, of XR, or augmented reality experiences for fashion brands, especially the medium sized and the small sized fashion brands. because they need an extra budget to get a 3D artist. So there is a lot of movement that is going into creating modern methods in this. So the first part is to generate fashion concepts from sketches using AI, and then using those images to generate 3D clothing models, again using AI. So for this, you'll check out ControlNet and the Facebook thing that I mentioned earlier. So this is an example. You can try this out for free using this link. Replicate is a cloud platform that allows people to host machine learning or these modern AI models, especially LLMs, and you can actually test out without paying. But if you want to integrate it within your product, I think that's when you can start paying. So for this, I just picked a random. I picked a random sketch online, and then using the sketch, I used the prompt a colorful dress in African prints, and in 3 seconds, it had this prototype of a garment. So you can see how AI can actually help fashion designers prototype faster, cheaply, and actually be able to focus on what now brings them money, which is manufacturing. So this is an example of using ControlNet, or this guided image generation technique that we talked about earlier, to actually generate concepts or fashion prototypes. And then this you can actually share with customers and get early feedback and iterate on it. The second one was, now once you have the image, you'd want to actually create the 3D model. And as we've mentioned, 3D modeling is kind of a hassle. So this is how the Facebook tool works. You give it an image, and then it extracts a 3D model of it generates a 3D model of that garment in that image, and this model can actually be used to can be simulated in 3D environments. As you can see here, this is a VR space that you can actually play around with the model, the garment, and actually showcase it to people who want to view it. And now you can imagine, now this is something that is accessible to people. What they just need to do is upload a photo of it. So we are going to see an influx of people joining, of fashion brands joining the XR space pretty soon. So this is the garment design. It's called Garment 3D Gen. It's a generative 3D model specifically made for fashion. It's recent. The only thing Meta has released is the paper, but they also announced that they will be releasing the code and the data used to train the model. So we are really looking forward to this. I think this will be one of the game changers of bringing uh, fashion brands, especially the small ones, those who don't have budgets for 3D modeling, on board to the XR space. Another interesting feature that we actually saw that ails the fashion industry is body sizing. And the reason why I'm saying this is, if you've worked in the fashion industry, you might have learned that every continent has its own size chart. So you'd find Europe has its own size chart, which is different from America's size chart, which is different from um, Africa's size chart, especially for women. We would find uh, women in coming from these different um, continents are built differently, so their shapes are not the same. So if you find that like a UK size 8 and a US size 8, they might not be the same. and this information is usually quite confusing to the end user. So for the end user, imagine you have to keep up and say, okay, this is a US size 8, so this might be bigger than what I'm expecting, because you are expecting UK size 8 to fit you. So there is a concept, and in using images to actually give you the actual size of your body. So basically what you do is you have to input your height, either in centimeters or inches, depending on how whichever metric you're comfortable in. And then you have to take two images. The first image is you have to face the front of your camera, and the second image you have to face the side, to get the body size uh, of the online buyers. Again, this will actually help a lot in reducing the online returns from the online sales. And the the key algorithm used here is the body part segmentation, and I'll show you in a bit. I think I forgot to add the example, but there is one called modi.ai. I think when I share the presentation, I'll make sure to add it. But mody.ai, they actually offer a service for this. So this is how it works. So if you've gone to a tailor before, I'm sure you've had your measurements taken, where they look at the different shoulder widths, they look at the pants length, they look at the hip, the waist, the bust, and all this. So as you can remember from the when we were looking at the different types of algorithms, we saw there was something to do with the body parts. So you can segment when you take a photo, you can segment a person in different parts. So how this algorithm works is, once you get those segmentation, you actually calculate the number of pixels that are in that, the length and circumference of pixels that in that body part segmentation group. So for example, if you want to calculate the sleeve length, you'd look for the body parts in this region and then calculate the actual length and circumference. That's why you're taking the photo of the front and the side. So the side is for the circumference bit. Now, once you have those calculations, you can actually now use the height that was input, because now you can now actually get the number of pixels from the top to the from the head to the toes. So you will know the number of pixels, the length of the pixels there, and you actually have the height. The user gave you the height, his or her height. So using that correlation, you can actually now calculate uh, the length, the sleeve length, the shoulder width, and the different uh, body lengths or sizing. So this has actually this revolution has actually helped a lot in identifying the size and recommending sizes. So for example, if you get this, there's also post processing to be done. So if you get the bust, the waist, and the hip, and let's say for example, these numbers that you get here, you'll actually need to now correlate them to, is this person a size small, a size medium, or a size large? There's a lot of because again it's using images or videos. There's a lot of XR that can be used here to build out the experience. The other application is personalization. For personalization here, it's kind of like, if you have a shopper, you'd want to recommend to them like some of the items that they would actually prefer. And so we've dealt, if you've shopped from Amazon or this big time e-commerce platforms, I'm sure if you go and view one product, at the bottom there will come and see similar products. So in terms of XR, you can actually go further and actually create a 3D product configurator where the user can come and actually change they can actually you can actually recommend like the colors. Maybe they can change, for example, you can see the person is changing the colors of the suit. They can actually change the types of collars, the types of sleeves. They can change, if they want a one button suit, they can change, or a three button suit. So these product configurators actually help people to actually build products that they want. And if you pay attention here at the bottom, let me just move here to this next one. If you pay attention at the bottom here, you'll notice that the price is changing. So the more people personalize their clothing, the higher the price. So you'd find they'd want, the same way that you'd go to like a tailor or a fashion brand that do bespoke items. You'd want for them to make a product that is yours. So through this, you can actually use 3D and a little bit of recommendation to using ML to actually guide the user to design their own or personalize their own products. The other one is brand verification. So this has been quite a big issue in the fashion industry. I believe in 2020 or 2021, Nike stopped selling their products in Amazon because a lot of people were selling fake products. So you can actually use machine learning and AI to analyze images of a product and actually uh, tell if they are authentic or fake. The algorithms used here is image embedding, image classifiers, and guided image generators. And this is how it will look like. So when someone uploads an image, it performs an image similarity search. So an image similarity search is actually uh, kind of like if you've used uh, Google search where you upload an image to search for items. It's something similar, and what that does is through image embeddings. So when image embeddings, as we discussed before, is creating a numerical representation of an image. So basically, it's looking at the numbers and saying which numbers are similar to this, and then once you get the similar images, you crop out the identity, which are basically the logo markings, and then do like identity detection, which is kind of like an object detection, and then a real slash fake classification, so you can actually tell if uh, an image is if a product is real or fake, and then use all this to actually compute an originality score. And this is actually something that we are working on internally. It's still under the testing phase, and we are looking forward to actually doing something in this. The final one, which is kind of like a fun thing to do, is virtual fashion shows and events. The key benefits of this is arranging for these physical fashion shows can be a little bit logistic intensive and expensive for the smaller fashion brands to actually participate in. So having like an immersive multi-user 3D space for people who can come in to showcase their products from designers in virtual fashion shows, or it can be just a virtual event. Um, users can actually access wearables from the fashion where they can actually dress their avatars, which can actually promote individuality. One tool that we saw that can be quite well with this is the recently released Microsoft Mesh. I think with this, because it's recent, I haven't seen someone do it yet, but I'm sure someone will do it in the future. So in the last section, we look at the challenges and opportunities. So the first challenge is the availability of training data. You'd find fashion is a really it's not something that is so super important that many brands have been working on. So you'd find that training data is not super available. Um, so there's a challenge with accessing the data. The second one is having on-device machine learning predictions. So you find like there's still a lot of models that can't run on phone. Thanks to Google's media pipe, at least we have some progress being done, especially in the LLM space. You through Google media pipe, you can actually run this something similar to ChatGPT on your phone. You can generate images, something similar to Midjourney on your phone. So Google Media Pipe is actually pushing boundaries in this. There's also the challenge of adoption of XR headsets, and if you're going to use like these big machine learning models, uh, having cloud GPUs, it's actually the costs are actually pretty high in that. But even where there are challenges, there are opportunities. The first key opportunity, I think, for anyone who's into XR and AR and VR is user experience, especially in the fashion space. There's a lot of experiments that can be done. I think we've just barely scratched the surface with this. So I think even if you find like people have done it, you'd find the user experience is a little bit wanting, if to say the least. The other opportunity is prompt engineering. You find, for example, if you want to create, if you're given a sketch of a fashion item, and you want to use this control net or these large language models to generate an image uh, using that sketch. So you'd find create writing those prompts is actually like uh, a task on its own. So there's a lot of opportunity in prompt engineering, and you'd find not so many fashion designers will be able to up to get acquainted with this skill. So what I've seen of late is people are starting to sell prompts. So there's an opportunity in prompt engineering and creating or designing AI agents. We'll also there's also an opportunity in creating learning materials. We don't have a lot of content when it comes to uh, creating XR experiences for fashion design. I think even for us as Klurdy Studios, when in our journey, we realized that, and it's not just for fashion. We realized that we had an opportunity to actually start creating content for the targets machine learning enthusiasts or people wanting to get into machine learning, especially when it comes to running on device uh, machine learning algorithms. And we just started creating blog articles, and we got a lot of hype around it, and we got opportunities to create like paid tutorials for big brands like Twilio, AI companies. And now we're at a point where we don't want to we want to move away from technical writing, and we want to start producing videos. So there's a huge opportunity in creating educational content revolving around this tech, especially for fashion. I don't think there's content for fashion specifically tailored for fashion. The last bit is synthetic data generation. What this means is so in the machine learning space, data is a problem. There's not enough. There's no enough data for fashion in order to train this algorithm. So synthetic data is you can use 3D to generate the images that you need to train this algorithm. So by synthetic it means it's machine generated data, but it is labeled and it can be used to actually train um, machine learning models. And one tool I've seen that is can actually supports this is NVIDIA Omniverse. Maybe you can check it out later. So for that, I think we believe that immersive experiences will rewrite how retail has been done in the past, and we live in an era where clothes are not just worn, they're experienced. So thank you for listening, and from here
Yeah.
I'll be taking any questions.
Yeah, sure. Thank you so much. I learned a lot from your presentation, and recently I'm doing the image recognition and also live like a detect. I used YOLO 8 in the past, but I start upgrade to YOLO V9, and I saw you mention that media pipeline. I don't know why when I searched the tool it didn't show up. So this is kind of like the first time that I know media pipe. Yeah, so I saw the media pipe. It looks so easy just to kind of like drag and drop, and you can do almost all the stuff that I'm looking for. So I would definitely get into that. And do you have any, I don't know, like a project that you use like all those like AI tools and I don't know if there's any published one you wanna share, or how do you get the project and what's your pipeline? And because we all know that right now, yeah, like who will be your kind of client who needs these types of like AR fashion service?
Yeah. So for fashion industry, the reason actually why I chose when I started Klurdy Studios is I chose fashion industry because I thought it was an industry that it was quite easy to get into and experiment with the technologies, because I think fashion since time and memorial they have been one of the industries that actually uptake recent technologies. So uh, what we've been able to achieve is collaborate with different companies along the way. We've not done like a product. I think we started working on our own product. I think almost 11 months ago. It will be. We are hoping to take it online next month. But it will be. It's not for fashion brands alone. It's for general brands, just for anyone. It's a platform for creating designs for branding and marketing. There'll be a little bit of merchandising. So for the merchandising, there'll be clothing items there where you can, and personalization, where you can come and for a brand, for example, let's say X Reality Pro, you can come and create your own hoodies. You can come create your own merch, basically merchandise, by uploading your logos, choosing colors, and adjusting all those stuff. I think that's one bit from the presentation you can experience. I think what we'd want to achieve in a perfect universe is brand authenticity and tackling the fake and authentic products. We had a conversation with LVMH. They were their innovation team based in China, and it was a little bit difficult to get them to sign them as a client, because at the time we were looking at using blockchain to verify authenticity of clothes, but we hit a wall because China does not support. I think they blacked out crypto. So we had to go back to the drawing board and come up with an AI solution for that. We still yet to review. So in terms of process of gaining clients, I think you can target fashion brands or fashion designers. I think having a pitch and submitting a pitch to them, and having them review, and then they'll ask to maybe see like a prototype or something, or a solution or how it works. So for example, if it's you want to create a virtual try-on, you might want to use like Snapchat's Lens Studio, because they already have the functionalities built in. So it's just a matter of reaching out to brands and telling them you create AR experiences as a service and for fashion brands, and you pitch to them. Uh, once they if they're interested, you might need to showcase at least one of their garments. So you might need to create a 3D model of one of their products and create an AR experience for that. Publish it on Snapchat. I think on Snapchat it's quite easy because number one, Lens Studio is free. Number two, I saw they released a functionality called Creative Kit, where you can actually use Lens Studio to create these experiences. But through Creative Kit, I think it's called Creative Kit. You can actually embed those AR experiences in your web app or your Android application. So you can actually create like your own branded solution, but actually under the hood it is Snapchat that is running the AR experiences. So I think that will be the process. Pitch, create a demo, and then yeah.
Oh, yeah. So do you have any like because I go to your website, do you have any like for example, you mentioned that Snapchat, you had like you encourage people to do like Snapchat like a fashion commerce. Do you have any like a study case or the project that you worked for the Snapchat lens or some
Mm,
other kind of like a study cases?
Uh, I think we do, but it's not documented. We haven't been big on documenting the case studies. Um, but there's the first one we did, which was when we were actually collaborating with Snapchat. Is there was a fashion designer who was based in UK. She was designing swimsuits and ladies ready to made wear, and we created an AR experience for that, and she ended up actually uh, selling selling her items on through Snapchat. So I think maybe I can as a follow up on this, I can try and see if I can get some documentation. I think it's here and there, it's scattered, but I can
Cool.
try and
Cool.
formalize it for you.
Yeah, cool. Yeah, no worries. Because a lot of my work I couldn't show it because it's under NDA, and I didn't follow up whether those projects are being published or not. So like my entire portfolio site was not up to date just because working for a client, sometimes they are not allowed to put on the put on the website. So I totally understand. Yeah, cool. Thank you so much for today's like a very informative, show us all the AI model. And I learned a lot just from like your introduction, like all the AI kind of like stuff. So right now, what do you see the I would say like metaverse, fashion, retail? What do you see this field? And in your kind of like experience, how can we, like, for example, what's the pipeline is the best? You mentioned that media pipe, right? That one is really good. And you mentioned that like using AI to create some 3D model. And before you also mentioned that 3D model, right now everybody is looking for like a 3D model for fashion, but Meta recently launched like the kind of like an AI generate the clothes, which really helps. So for you, what do you see? Like for example, like who might needs it, or like as a creator, if someone is very interested in creating like a XR AI for fashion, what's your recommendation and suggestion?
Mm. I think we are heading in a very we are heading in the right direction, and we are heading to a very interesting space, because especially for 3D fashion, it does not just turn into retail. There's this big, gigantic industry called gaming, and all games, you find the characters have clothes. So you'd find there's a lot of underrepresentation of the different fashion items available in games. So you'd find a lot of games have a specific type of clothes. So you'd find maybe clothing items from Africa, clothing items from different parts of the world are not well represented um, in games. So with these new technologies that help fashion designers, fashion brands, gamers to actually create assets, 3D assets in a timely fashion without having to spend a lot of money. It will help to actually change the wearables market in gaming, because as you can see, like, for example, Fortnite, the game, um, people buy a lot of skins. That's why people love Fortnite. Like the skins is one of the biggest hits in Fortnite. Individuality. People want to feel they are themselves in these digital realms or in the metaverse. So again, also with the metaverse, you'd find clothing items for avatars will be diverse. So there will be a lot of individuality in that. I think for people who are in the XR space and want to uh, start on clothing design, I think the best place to start is to to learn prompt engineering, because that will be like the beginning of everything, because you'll be able to sit down, draw out a sketch of whatever you're imagining in your head of a clothing item. But in order to generate an image version of it, a high fidelity image or a prototype of that fashion item, you need to learn uh, prompt engineering in order to create that. And then from that image, through Meta's new AI tool, you can actually now create the 3D version. um, I think also we need to actually look at the different uh, platforms out there for creating these metaverse experiences, because virtual fashion shows, it's something that is has a lot of potential, in it, because you find, I think every quarter of the year, or is it every half of the year, different cities host different fashion shows. So you find that, like for Italy, it's Fashion Milan. For UK, it's London Fashion Week. Even for US, I think you'll have like New York Fashion Week and the likes. But you'd find, all these fashion weeks, they are not, people, unless you are in the city, you cannot attend them. The only way you can actually experience them is, watching a review online. So you can imagine them having a mix of, in-person fashion shows and having like a virtual fashion shows where people see, where a person seated anywhere across the world, they can be able to, with the help of a headset, they can be able to actually experience, those fashion shows. And it will actually, fashion is a big part of the creative culture. So I think we are heading in a very interesting, space. There's a lot of opportunity in it.
Cool. Yeah. And for the fashion, you mentioned that start with engineering, and we have a lot of audience. They are from UX UI background. And what do you see? Because personally, I'm from like a UX UI background, and I start realize how important that coding is. Like within this few years, like last year or 2 years ago, because I wrote a book. It's about like how designer can become a good XR designer. But I emphasize coding as well, just like you said, because I find out that the entire, I would say from 2D to 3D, 2D you can use Figma and doing the tabs through like entire hierarchy. But for the 3D, it's pretty much more like a theme park experience. It's more about how you tell a story, and the pop up like a 2D Figma part is almost like a people are intended to limited those. And I feel like the experience and also 3D skills versus game development skills is much more, I would say 95% of it. So I totally agree. And also keep up to see what's the tools, because for example, engineer might not be really good at 3D model. Maybe tons of people are very good at, but for those who only knows more like engineer part, they can use leverage the tools through, like for example, Meta has Garment 3D. Pretty much you can give it a 2D image, and it can start making a kind of like a 3D human and wearing that texture of clothes. So I do agree with you that for the part. And what do you see that, for example, like we have a couple people, I would say 50% of the audience, they are from product design background, and they used to do like a 2D screen. And a lot of people are very interested in jumping to XR field. And I know that for the Figma part, it will go less and less. And also there are a lot of template. You don't even need to design that part. So what do you recommend, for example, like a starting point? For example, what tools is mandatory, like a Unity or like a Python, PyTorch, or what do you suggest if someone wanna be more like you, but from the design aspect?
Thank you for that. I think you've reminded me, even me when I started my company. I was a 2D designer. I had not done any 3D design. That was in 2019. Um, I was new. I was very experienced in 2D design. So, using the Adobe, products, even the Figmas and tools. But 3D was a bit different. And, first, I had to learn, thinking from a 3D perspective. And by 3D, I mean, learning the depth aspect of design. And by depth, I think it's called the z-axis. That was actually one of the first things that actually took me a lot of a long while to actually be able to understand. So if you're coming from 2D and you want to jump into 3D design, I'd advise learning the depth, because the two-dimensional part, you're already a designer. You already know colors, you already know the fundamentals of design. The only key difference is the depth, um, which took me quite a while. I think that's something that you people need to learn fast. When it comes to tools, for me, I started with simple tools. In terms of 3D modeling software, I think Blender is a good it's a good place to start. If you want to learn 3D modeling, the reason I'm saying that is, number one, it is open source. Number two, it has a really big community around it. So if you need 3D models that are already created, you can actually get access to learning materials on YouTube, or just free models that you can download and start hacking your way around it. When it comes to uh, development, I'd say Unity is a bit too much, because for a beginner, you need to learn the programming language of Unity is C sharp, and C sharp can be a bit overwhelming at first. Um, I think if you want to start with XR, the best place I'd advise is start with these editors from social media companies. Like, for example, if you want to publish an AR effect on Snapchat, you can use Lens Studio. And through Lens Studio, they have if you want to publish on Facebook or Instagram, you can use Spark AR. Uh, if you want to publish on TikTok, you can use Effect House. So the beauty of those three tools for those three platforms, uh, they are kind of similar between them. They kind of like look the same. I don't know if they have the same. They kind of like share the same interface ish to some extent, and they might have some similar functionalities here and there. And the good thing is you can create AR effects without writing a single line of code using them. You can use node-based editors in them, to where you can just drag and drop stuff to create like logic. I think that will be a bit comfortable for someone who's starting, for someone who's coming from a product design background, or a non-technical uh, background, or someone who has uh, little to no experience on coding. If that same person wants to experience with machine learning, I think I left a link on the no code machine learning tool from Google. They have it was recently released, I think, towards the end of last year. It's a good platform to start with creating your own machine learning pipelines or your machine learning experiments. And it actually can be used to learn on how these amazing tools work. And once you gain an understanding of how things work within, if it's for AR or 3D or machine learning, from there, now you can actually now dive deeper into learning coding. So for learning coding, I think the key, if when you want to choose the programming language, I think the individual needs to ask themselves the platform that they want to deploy their AR effects. So are you targeting browser-based augmented reality effects, or do you want to create like an Android application, or do you just want to create like an online service, like an API or stuff? So if you'd want to do browser-based AR effects, I think JavaScript will be your friend. And the good thing with JavaScript is also these softwares for social media companies that are used to publish AR effects. They use JavaScript as the programming language. So JavaScript is widely used. I think JavaScript is fairly easy to learn. It's quick, it's easy to learn. Also Python is easy to learn, but Python can be used to now if you want to like code your machine learning algorithms. Unity is good, but the programming language is C sharp, and C sharp can be a bit daunting. So I'd say Unity, you preserve it for the last, but the beauty about Unity is you can publish your AR application on iOS, on Android, or even the web. So it has that nice cross platform feature. But also remember, JavaScript can run on any device. So every device has a browser, so it can run on desktop or uh, or a mobile. So I think that's how I'd approach it.
Cool. Yeah, thank you so much. And I look up the chat right now. It seems like people are like sharing some links about what you mentioned. Yeah, so yeah, let me see. Anyone wanna ask Brian questions? Feel free to post it. Yeah, I saw a bunch of people are posting like the 3D model URL, like Peter posts like 3 or 4 of it, and I catch up and post more when you mentioned. And yeah, thank you so much. And I haven't seen any comments so far, but I think we can sync offline. If anybody has any questions, feel free to reach out to Brian and ask more questions. Yeah, thank you so much. And yeah, wish everything goes well to your career, and thank you so much for your time to speak for the event. Yeah, thank you. Bye bye.
Okay, thank you.